Alright, welcome back to Explain 13.1. We'll be going over this lesson starting with Explain 1. So just like it shows in your example packet, it says to state the domain and range of the given function. Then identify the new values of the reference points and the isotope. Use these values to graph the function. So the first thing I pulled from your textbook was just this basic exponential function. So this gives us kind of where all the values that we're going to be looking for lie. As you can see here, our first value is going to be a, which is -3. Here you can see that our h value is actually 2, and our k value is +1. We're going to use these values to transform each of the points from the parent function. So our h value here was 2. Our a value was -3 plus 1, and we can simplify this. So that would be 2. What would -3 plus 1 be? -2, right? Next thing we're going to do is take our point value, and we're going to use our h, a, b, and k value to find the next point on our graph, which would be 1 plus h was 2. Our a value is -3 times our b value, which is, in this case, I almost forgot, 2. Our b value, which is 2, and our k value, which is 1. Let's take some time to simplify this out. What's 1 plus 2? 3, right? Take some time to simplify out -3 times 2 plus 1. And that would be -5. So these are the 2 points we're going to use to graph our line. And then our isotope would be y equals whatever our k value is. We found our k value to actually be 1. Alright, on this next slide we're going to go ahead and take these values that we found here to go ahead and graph. So as you can see here, it's actually already graphed for us on this slide, and actually I pulled this from our textbook because they did graph this for us. So there's 2, -2, as well as 3, -5, and our isotope. Remember an isotope? Because I know this was from a while back. Our isotope is actually just going to be a line that our graph gets really close to, like really close, but never actually crosses. If you want to think about it, it's kind of like a limit. There's just a certain value it's just not going to cross, and that's as much as it's going to get. Alright, so to identify our domain and range, which is the last part of our the problem that we're doing, remember our domain is going to be all our x values, and I could write it as a sentence that I can have all negative and all positive numbers, because as you can see here, I have x values that are -1, -2, -3, 0, +1, +2, +3, 4. But there is a mathematical way to do this. So we're going to use the infinity symbol, which kind of looks like a sideways 8. So we can go from this symbol here, which is a -infinity, and that includes just all the infinite numbers in the negative direction and all the positive numbers in the infinite positive direction. And x essentially can be any number in between those two values. So this is just a mathematical way of writing, hey, the domain can be all positive and all negative numbers. Now for our range, however, there is a limit of how tall or what value the y value approaches. In fact, as we can see here, our graph gets really close, but never actually quite touches the y value of 1. So for here, our range, which is all our y values, could be any value for y. that's less than 1. So it could be 0, as we see here. There's a point at, on the y level 0. There's a point for the y level -1, -2, -3, -4, -5. So there's all these points, but notice that they don't go any higher. That's kind of our limit for 1. Alright, so moving on to the next problem that we're going to do. So here we're given q of x equals 1.5, 10 to the x minus 3 minus 5. Alright, so what we're going to do first is going to go ahead and identify our a value, which is 1.5. We're going to identify, even though I don't put a space here, I'm going to identify our b value, which is about 10. Our h value, which is 3, and our k value, which is about -5. Okay, we're going to use these numbers here to kind of find out what our points and our isotope will be so that we can graph it. So using those values, in fact, you'll see here that they kind of started to help us out here in working out, finding out our first point. So here they substituted in 3 and 1.5 and our -5. So we're going to take some time to go ahead and simplify that out. So we'll 1.5 take away 5b. And that would be about -3.5. And then again they took some time to substitute in our h value, which is very nice of them, our a value, our b value, and of course our k value. So take some time to simplify this out. And that would be 4, 10. And our isotope would be our k value, which was -5. So we're going to take some time to go ahead and graph these out. So as you can see here on the graph you have provided here, it's a little not drawn with all the numbers that we need. So I'm going to kind of write some of these down. If you're wondering where are the odd numbers, you can write those in the middle. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. This just helps to kind of being able to graph. So let's go ahead and graph the first one, which is 3, -3.5. So that'd be 3. And that would be about 3.5 right there. 410, that would be about 410 right here. Oh. And then as you can see here, our isotope is actually going to be down here, where our graph doesn't kind of go past this point. So let me write this one more time. So you can see that it kind of slopes, and this is a sketch, so it's okay if it's not perfect. But you'll notice that it kind of goes in that direction. And the last thing we're going to do is find our domain and range for our function. So here, remember that we can have negative values for our x value, we can have positive values. So all positive and negative values, and there's a fancy way we write that with a negative infinity and a positive infinity. Okay. Now for our y value, we see that actually we can have any y value that's positive and even a couple of negative values here. However, all the y values are greater than the lowest value, which tends to be our isotope, which in this case was -5. So take some time to do some of the problems in the example packet so that way you can, from your packet, so that way you can get some practice. So there is a problem in here that's like explain 1. Go ahead and do that right now.